today from the Shuttle Gallery in the Cosmosphere's Hubble Space Museum. Today we'll be hearing the first-hand account of former shuttle astronaut Dr. Hawley, who flew 5 space shuttle missions, including 2 to the Hubble Space Telescope, where he was on the deploy mission, as well as the first service mission. I believe Dr. Hawley has his trusty sidekick Peyton there with him as well. If you have questions as you listen, please type them into the chat feature on Zoom or Facebook. And if we have time at the end of the presentation, we'll ask some of your questions. Also, if you'd like more information on Hubble, join us again this Thursday at 9 a.m. Central for our Coffee at the Cosmo, where we'll continue the Hubble anniversary celebration. And finally, we are over the moon excited to announce that the Cosmosphere is safely reopening this Friday. After 2 long months, again, we are reopening this Friday. We're very excited to see all of you back here at the Cosmosphere. For more information on our safety procedures, hours, and more, visit cosmo.org, cosmo.org. Okay, now, if we can welcome Dr. Steve Hawley. Steve, it's great to have you. Unfortunately, I wish we were under different circumstances. I know you and Eileen had worked to put together a great anniversary event here, but unfortunately, due to the COVID, we had to cancel that. But we're here together, we're here live, and we're going to talk about all things Hubble. So welcome, Dr. Hawley.
Thank you, Jim. It's great to be with you, even though we can't be physically together. And hopefully we'll get a chance to get the whole crew together in Hutch before too long anyway.
Absolutely, and I'd be remiss if I didn't point out you're wearing a Hubble shirt, and then you have one of the only still images taken of the Hubble deploy behind you there.
Right, on the wall. Actually, the way the deploy happened was kind of a hybrid of the 2 different situations we had trained for. A situation where all 5 of us were involved at the deploy, and a different situation where 3 of us were inside and Bruce McCandless and Kathy Sullivan were EVA, helping to solve the problems that were preventing the deploy. And the situation we actually had was 3 of us were busy on the flight deck with the deploy, and Bruce and Kathy were in the airlock, prepared to go outside, but the situation that had driven them into the airlock was resolved. And the reason all that matters is they were the photographers. And so the photographers were in the airlock, and we were smart enough to at least turn on the IMAX camera, which was filming the release for Dream is Alive, I believe. Might be Destiny in Space. Forget which movie that sequence was for, but the IMAX folks were kind enough to give us a frame out of the video. So that's the one still that exists.
So do you give the 2 that were in the airlock a hard time that they weren't actually there for the actual deploy?
Yeah, unfortunately, we gave them a hard time at the time because there were some possibilities after the initial problem, which was a solar array problem. Once that was resolved, there were still some other things that could happen, and the fact that they were already prepared to go outside, it made sense to leave them in that situation. So yeah, I have to admit that after the deploy, and we were beginning to move the orbiter away, and we were now taking pictures because we were free to get our hands on the cameras. Knowing they were in the airlock and couldn't see anything, we were very effusive in our description of how beautiful and stunning and once-in-a-lifetime opportunity this is to see this thing. And finally, I think Kathy told us to just shut up.
Steve, describe being selected as part of the Hubble deploy mission. Was the training different or more complex than your previous shuttle missions?
It was an honor to be picked to be part of the Hubble mission. Initially, Charlie and I were training for STS-61C when we were assigned to the Hubble mission, and that was in 1985. And so one thing that was a bit unusual was that Charlie and I were both training for one flight, but we were also assigned to a subsequent flight. Plus, we got to fly together 2 flights in a row for each of us. When we were initially assigned, John Young was our commander, and that was an honor, of course, to be assigned to fly with John. Of course, Challenger accident changed all that, and the
Hmm.
crew assignments were redone after return to flight. But uh, in many ways, the training was similar to what I had been through before. Actually, I was the most experienced of the crew members. This was my third flight. The others were flying their second flights. But so a lot of the shuttle systems training for me was familiar. The thing that was different was the Hubble um, payload introduced a whole lot of complexity in the mission design. So it was kind of a combination of how do you put this mission together? And in a second, I'll tell you some of the things we wrestled with, and
Great.
then how do you train to do it properly? One thing was, for me, the Hubble uh, was a new experience because I had to learn how to use the robot arm. Hubble was deployed from the shuttle with the robot arm, and I hadn't used the arm on my two previous flights. I enjoyed that a lot, but it was all new. Hubble was large. It took full advantage of the volume of the payload bay. And so the clearances around Hubble, the clearance between Hubble and the shuttle were very, very tight. The Hubble telescope was also fairly massive. It was about 24,000 pounds. And one other complication was as you begin to move it farther and farther away from the center of gravity of the orbiter, the automatic flight control system becomes unstable. And so we had to develop a way to maneuver the orbiter, which if I remember right, we called manual min impulse, but it meant that the commander, Lawrence Shriver, could move the orbiter, but Hubble had to be stationary, and he had to do it manually by making individual inputs on the control stick. So he had to learn how to do that, and we had to train on the coordination to make sure that I knew when he needed to move the vehicle, and he knew if the Hubble was in motion to not move the vehicle. Hubble itself had a number of constraints for communication, things that the sun needed to point at, things the sun should never point out, um, viewing of critical steps in the deployment of appendages. Anyway, so the whole thing was quite complicated choreography that we had to both develop and then learn how to execute it. And so, yeah, that was kind of complicated.
How did you train to use the arm? Did you do that virtually? Was it set up in the MBL to where you trained that way? Or talk to us about the training process specifically with the arm.
Yeah, there were several facilities. Some of them were virtual. A couple of them were more real. We, of course, had the arm modeled in our shuttle simulator. That wasn't the first thing you get to use. We had another facility called the Shuttle Engineering Simulator, which had a shuttle model, and that model I thought was much better, replicating the actual behavior of the arm. We also had some part task trainers. We had a computer that had a shuttle arm model in it, and it had a control stick, so you could fly it around and get some training that way. And you mentioned the NBL. We actually trained both at Marshall at the time. For this was specifically for STS 82 now, where we have the EVA tasks and the robotic tasks simultaneously. So we didn't use the NBL or the Marshall facility for 31, but when we were training for 82, we did, and that had a real arm, but run hydraulically,
Right.
and that was good. The NBL was better, and that was very realistic training. So there were probably 4 or 5 different facilities that you could get exposure to different ways the arm performed. The one that was probably, in a sense, the most real was something called the MDF. It was a manipulator development facility. It's actually one of the stops we used to have on the Cosmo tour of JSC in Building 9. And it was a real mock-up of the payload bay and a real arm, and a real life-size cockpit, so you could stand where you would be standing in real life. You could look out the window and have the view that you would have in real life. You could actually drive the HST model into the shuttle if you weren't careful. So in that sense, it was quite realistic. It gave you the real sense for what this thing's going to look like coming out of the bay and how it's going to block your view, and learn how to use the TV cameras to give you the views that you need for the deploy operation. The bad thing about it is HST was modeled with a huge helium-filled balloon. And so they had to turn off all the air conditioning in the building because the currents would move the balloon around while it was attached to the arm. And so that was kind of negative training, that the balloon wasn't really stable and it would kind of move around. But if you could move the balloon properly, then we had confidence you could actually do HST.
Looking back on what Hubble has accomplished, do you, as the crew prepared for the mission, and then as you deployed, were you aware of the significance that Hubble represents, and what it has come, or is hindsight, after so many years, did you come to appreciate it even more?
Well, as an astronomer, I had probably a different level of
Right.
appreciation for what it could do than my crewmates did, but we all knew how it was being advertised and what the potential was, and some of the notional discoveries that we hoped it would make. So yeah, we all had high hopes, and we knew that we were a small part of something that was probably going to be revolutionary for astronomy. And we certainly hoped that it would achieve its, at the time we launched, I think it was a 15-year design life, and we hoped it would do
Right.
that. And yeah, in hindsight, I would say, at least speaking for myself, that I probably underestimated the impact of Hubble on science, and frankly, also perhaps on how the public would react to it.
Mm-hmm.
The thing that's been really interesting and gratifying is that, as you know, it's been there 30 years and it's still very popular. And there weren't a lot of things that NASA did that could sustain popularity over decades,
Right.
and Hubble has managed to do that. In fact, it was, the public's refusal to accept the lack of a final servicing mission that motivated Congress and others to lobby to have the final servicing mission reinstated. And of course, it eventually was, and that mission took place in 2009. So it's been, I used to say, when I would fly commercially a lot, and sitting next to people on the plane, these are people that thought the shuttle launched from Houston and went to the moon, but they had heard of the Hubble Space Telescope. Everybody had heard of the Hubble Space Telescope.
As an astronomer, what in your opinion was Hubble's most impactful discovery?
Yeah, that's a tough one to just pick one of all of the discoveries. I'll answer your question in a second. One of the key questions that Hubble was really designed to solve was the determination of the Hubble constant,
Mm-hmm.
which is a relationship in astronomy that measures the expansion of the universe and also can tell you how long it's been expanding, which then tells you the age of the universe. And when we launched HST in 1990, that was one of the big problems in astronomy, because the Hubble constant was not known to a factor of 2. And what that meant was the universe was, one set of measurements said the universe was 10 billion years old. That didn't make a lot of sense because we knew there were stars older than that. But another measurement said it was 20 billion years old. And we needed to see if we could narrow that down. And that was one of the first major problems that Hubble solved, was the determination of the Hubble constant, and measured the age of the universe to be 13.7 billion years. However, I would say that things that were discovered after that maybe were a little more profound, and I'm thinking specifically of the discovery of dark energy. In an attempt to refine the measurement of the Hubble constant using the Hubble telescope, scientists were looking farther and farther away. at very bright supernovae, and what they discovered was just mind-blowing, and that is that yes, the universe is expanding, and we had always assumed it was slowing down, and the question was, would it going to ever slow down to the point where it might reverse and recollapse? And what they discovered, two independent groups discovered that the expansion is actually speeding up. And that was such a shock that I remember thinking at the time, that's the dumbest thing I've ever heard. And it has now been confirmed, and we have no explanation for it. We have a name for it. We call it dark energy, but we don't know what it is. And that probably is arguably the most profound issue in astrophysics, is what is dark energy, and what is the ultimate fate of the universe as a consequence. So if I had to pick one, I'd pick that one.
Hubble is obviously 30 years old. Talk about the design of HST. It's stood the test of time. Some of the technology that went into it was leading edge, still relevant. The design itself is something that is still significant. Talk a little bit about that.
Yeah, well, going back to the beginning, the fundamental design concept was based around the fact that history says we build things actually pretty well, and when we launch spacecraft, they work for a long time, generally much longer than their design lifetimes. But the problem is that over time, the detectors on board these orbiting instruments basically become out of date or wear out.
Mm-hmm.
And the idea was, well, could you design a telescope that would be state of the art when you launch it, but over time you could take new instrumentation, as new detectors are developed and new uh, instruments can be built, could you take the new instruments and put them into the orbiting observatory and keep the technology state of the art, keep the telescope up to date, and also deal with any failures. If something fails, can you replace it on orbit so that the telescope would not suffer the fate of being obsolete just because the technology was old? So that was kind of the revolution in the design. The telescope itself is a telescope design called a Ritchie-Chrétien. It's like a Cassegrain. It has a main mirror with a hole in it and a secondary mirror, so the light comes in the open end, hits the main mirror, reflects to the secondary mirror, and then back down through the hole in the main mirror. And beneath the main mirror are the four main science instruments. So that's how that's designed. And then around the perimeter of the telescope, there are three fine grained sensors, which are instruments in their own way. And the wide field, well, when we launched it was the wide field planetary camera. Now it's the wide field camera. So depending on how you want to count, there's 8 science instruments aboard, all of which were designed to be upgraded over time. And a lot of the systems were designed to be upgraded, things like reaction wheels, things like gyros, were potential solar arrays. We've replaced solar arrays twice. All of those were designed. There were some other components, though, that failed over time that were not designed to be replaced or repaired, and we replaced or repaired them anyway. And that was another set of challenges. How do you figure out how to do that? So the design was intended to allow us to keep the telescope operational and state of the art, and I would say it has done that, even though we haven't been to it since 2009.
There was a question that someone from the audience asked specifically about the fact that we haven't been back to Hubble or serviced it since '09. It's obviously going to come out of its orbit, and without an ability to boost it back into orbit, will Hubble suffer a similar fate to Skylab?
Well, it will suffer a similar fate in the sense that it'll enter the atmosphere and burn up. In the case of Skylab, the entry was uncontrolled. And so there was concern at the time about components that would survive reentry, landing where people could be injured.
Mm-hmm.
Fortunately, that in the case of Skylab, that didn't happen. The entry was uncontrolled, but it didn't land in a populated
Right.
area. The Hubble, the intent would be to target it for a controlled reentry, presumably over the ocean,
Mm-hmm.
because we know that some of the components will survive. To enable that, on the last servicing mission in 2009, the crew attached a fixture to the bottom of the telescope that someday, presumably a robot spacecraft could dock with it and then put it in a controlled reentry. So that would be the plan. Hopefully, that's not something we need to worry about right away.
Right.
Uh, we, I remember we did a calculation before the last servicing mission, how long we thought HST its orbit would last, and that calculation, as I remember, was somewhere in the 2030s.
Wow.
And the reason we did the calculation was because there was consideration given at the time to not doing a reboost on the last mission, and in fact, we did not do a reboost on the last mission.
Were lessons learned from Hubble used in the design of the James Webb Telescope? Do you know?
Well, I am sure that's true because, I mean, for example, how do instruments behave in space? What's the
Right.
cosmic ray background like? Do you need to protect them from radiation more robustly, or is what we did on Hubble good enough? Now, James Webb's in a different environment, and so it's going to be exposed to a different set of conditions. But the design of Webb is different also in the sense that it is not repairable. I mean, who knows what you might come up with if you had a
Right.
need, but it's designed to be totally autonomous. It's not in a orbit that's easy to get to. All of the things that make it operational and have to deploy have to do so on their own. The mirror, the sunshade. I was concerned. I remember before I left NASA, I was concerned that what if that doesn't all go properly? You don't really have a capability to go fix it. And I had suggested that what they could do would be take we called it a grapple fixture. It's the pin that's on HST that the arm grabs onto. Put one of those on James Webb, and then maybe you could send a robot if you needed to, and it could grab onto it. Maybe you could just shake it and get something to come loose. I don't think they ever did that. So it's not just Hubble. We've had lots of experience with orbiting telescopes, orbiting instruments of a variety of kinds, and all of that goes into the development of a new system. But Webb is unique in where it's going to orbit and how it's going to deploy its mirror and, as I say, the sunshade.
As an astronomer, that's got to excite you, though.
It does. It has a lot of potential. It's often said that James Webb is a successor to HST. I tend to reject that claim because it's not. Scientifically, it's totally different. It's designed to work in the infrared. It's designed to look at galaxies that are way, way far away. They're galaxies that formed in the very early universe, and therefore their light's redshifted substantially into the infrared. The hope is that we'll also be able to find the very first stars that formed in the universe. Again, their light would be redshifted far into the infrared, but Webb has an aperture large enough and sensitivity that we hope to be able to find them, and that would be very exciting. However, it doesn't do what Hubble does, and once Hubble is no longer operational, we won't have a telescope in orbit that'll do what Hubble does.
Right. Well, there really hasn't been Hubble's unique. You talk about James Webb being the Hubble's predecessor. There really hasn't been a predecessor to Hubble.
No, in fact, it's interesting that when we were building Hubble, part of the reason that Hubble was built in the first place was because we really thought we had done about as well as could be done from the ground. The Palomar 200-inch telescope was the biggest mirror we thought you could build successfully. We've got the atmosphere that introduces turbulence into your uh, observing. If you find a nice stable air mass over a mountaintop, you might be able to see, a little bit better than an arc second resolution. And so we felt in order to push the envelope, we needed to get above the atmosphere,
Mm-hmm.
and we needed to, even though Hubble's diameter is less than half of Mount Palomar's, it
Mm-hmm.
would still be a better performing telescope. And all of that turned out to be true. The thing that we didn't anticipate back in the 60s and early 70s were the developments in ground-based astronomy. And specifically, yeah, you can't really build a huge glass mirror bigger than 200 inches and have it work very well. But if you've got enough computing power, you can build a whole bunch of little mirrors
Mm-hmm.
and piece them together and operate them individually to function as one large mirror. And suddenly now you can build a 10-meter telescope. And you still have the atmosphere to mess with, but if you shine a laser into the upper atmosphere and it will cause sodium atoms to glow, you can use those as artificial stars, and you can maneuver the individual mirror segments around to compensate, at least in part, for some of the turbulence introduced by the atmosphere. That's called adaptive optics. And so segmented mirror technology and adaptive optics have made ground-based astronomy incredibly relevant. And so now the paradigm is that with Hubble, particularly with respect to the Hubble deep fields, you can find some objects that are very, very faint, but look very, very interesting. And then you can go take a 10-meter telescope and observe them from the ground and get a spectrum. And these things will accumulate more light than HST will, just
Right.
because of the aperture. And so the teamwork between sophisticated ground-based telescopes and the orbiting telescopes, not just Hubble, but also Chandra and,
Sure.
and Spitzer when it was operating, um, really have said that the 30 years that we're just recognizing the anniversary, that those 30 years represent a tremendous advance in astronomy, due in large part to Hubble, but it's also due to large advances in ground-based astronomy and the ability to work together using space-based assets and ground-based assets.
In your blog, one of the first things you talk about is how you remember the mission, the deploy mission, like it was yesterday. Was that true for your other missions, or did Hubble hold a special place in your heart, so to speak?
Yeah, the two Hubble missions were special. I mean, I probably remember more detail about those than I do some of my other flights. I mean, it seems a little funny to say, you flew in space, but you can't remember what happened. No, but some of the details are a little sketchy. But we've had occasion to go back and talk about some of the things that we did, some of the things we learned, and some of the lessons learned from that mission
Mhm.
were incorporated in the other missions. So we had a chance to review some of the things we've done 31 on 82. If you would permit me a story.
Yeah,
Um,
of course.
one of the things that happened on 31 was when we went to deploy HST, and I was kind of reminding myself some of this because I've got my HST deploy checklist here with me. Um, there's a TV camera on the end of the robot arm, and you would use that to guide the arm as you back away from the telescope to not make contact with this grapple fixture pin that I was
Mhm.
mentioning earlier. Well, as you know, the telescope is covered with very reflective surface for thermal reasons. And the sunlight reflecting off of the telescope was so bright that it overwhelmed the camera and the camera was useless. And fortunately, I had a good view out the window, so I could do it just using my eyes. But when we got back, I recommended that in the future for the servicing missions, you should probably do the capture at night,
Hmm.
because if you didn't have that camera working and you were trying to capture the telescope, it'd be very, very difficult, maybe impossible. And so that was adopted for the first servicing mission. So now we get to the second servicing mission, and I'm assigned to that one. And they want to put a color camera on the end of the arm to get a better photo survey of the telescope after we capture it. We always flew a black and white camera because it had better low light level sensitivity. And I was really worried now. I knew the color cameras were fairly poor in the dark. And I thought, well, now I'm in a situation where I'm trying to do this thing at night and I get this color camera. So I expressed some concern about that. And I said, well, why don't we just do the capture in the daytime and then we don't have to worry about this? And they said, no, we can't do it in the daytime. And I said, well, sure you can. And I started to explain, orbital mechanics and rendezvous and launch windows. And the guy said, no, it's not that. He said, the deploy crew said we can't do it during the daytime. And I went, yeah, I did say that. But we ended up doing it at night and it worked fine. But yeah, there were a lot of lessons learned that were incorporated in the subsequent servicing missions, which allowed me to go back and review some of the things we did on 31.
So if you orbit every 90 minutes, what was your window then to capture at night?
I don't recall exactly. I think we probably had 10 or 15 minutes.
Yeah.
But I don't remember what it was.
Not stressful at all.
I was a little worried until we got there, but the Payload Bay floodlights were good enough, and the telescope was so reflective that it was really not an issue at all. Matter of fact, the telescope was so reflective. I remember after the deploy, we were loitering around at I think it was 60 miles in case the aperture door didn't open, and then we'd have to go back and capture the telescope, and then Bruce and Kathy would go out and open the aperture door manually. You could see it. I mean, you could see it was a bright star, easily seen from that far away.
Wow. Do you think, is Hubble done discovering? Are there other opportunities that you think Hubble could find? Or
I am sure it is not.
Yeah.
In fact, it'd be nice to have some overlap between Hubble and Webb. There are some studies you could do. Hubble might find some really nice targets for Webb to go after. But yeah, the telescope is still a very good science instrument. Mm-hmm. The gyros have been slowly failing over time. We've always had gyro problems, but it's still doing tremendous science. And one thing that's not maybe commonly known is that as an investigator, if I apply for time and my application is approved, then I get my data and I have priority access to it for a year. But after a year, it goes into a database, and anybody that wants to see it can see it and use it for perhaps research on some other topic. And that happened, I think it was maybe in the last 5 or 6 years that we transitioned from the point where more papers are now being written on using archived HST data than are being written on PI data.
Oh, wow.
And that archive will be there forever.
Right.
And so even after Hubble is no longer operational, you'll still be able to data mine the archives, and I would imagine a number of important discoveries to be made. One of the things that has happened over time is the ability to do data processing has increased so much that you can take an image that was taken 10 years ago and suddenly you can process it in a different way and reveal secrets that were overlooked.
As an astronomer, what is your hope for the next discovery that might be out there?
Well, one of the things that Hubble has been doing, and Webb will be able to do better, is now that we know there are planets around other stars, what you'd like to know is, are any of them Earth-like, and what does that mean, Earth-like? Well, it could mean, are they Earth-sized, are they Earth mass, do they have an atmosphere? We think one of the most important things would be if you could find characteristics of an atmosphere that would suggest there's life present. And Hubble hasn't found indisputable evidence of life, of course, but using Hubble, we have been able to probe the atmospheres of planets around other stars. Hubble's discovered water in the atmosphere of some planets. They've discovered organics in the atmosphere of some planets. None of that's conclusive yet, but it's beginning to show what we might be able to do. One of the ideas behind TESS, which is a satellite that was launched a couple years ago to replace the Kepler satellite, TESS is looking at looking for planets around stars that are relatively nearby. And the advantage of that is if you could find planets that are worth a second look and they're close by, then Hubble or James Webb would have a better chance to really characterize the conditions, find out what's in the atmosphere. So, that would be my hope is, maybe the next big thing would be getting a handle on some planets around other stars that look really promising in terms of potential life. If you found oxygen, that would be a game changer because we really don't know how to put a lot of oxygen in atmosphere absent photosynthesis.
I don't have the targeted or projected launch date for Webb off the top of my head. Do you recall that, Steve, when they're hoping to launch Webb?
I think it's mid next year.
Okay.
Yeah, somebody listening in may know specifically and can share that with us, but I think it's middle of 2021.
Okay. Oh, someone just say
March 2021. Okay.
March 21. Yep. Carly, you have a question? Yep. Question, Steve. How are the target areas chosen? So for Hubble and Chandra, Webb, how are the target areas determined?
Two ways. The most common way is that as this is a national facility, and so any astronomer can request to do a project and submit a proposal that would name specifically targets that he or she wanted to observe. That competition is pretty intense. There's somewhere between 5 and 10 times more applications for time than there's time available to award. But some of the targets, therefore, are chosen by investigators who have a specific thing they want to do. Also, there's something called director's discretionary time, and the director of the Space Telescope Institute can pick a place that he wants to scientifically valuable. The deep field's a good example. The first deep field, Bob Williams was the institute director, and he devoted director's discretionary time to take a deep photograph of what we thought was probably an empty place in the sky. So those are principally the two ways. It's a little more sophisticated. Sometimes the director will ask a team of scientists to get together and propose a series of targets to study that would be generally of interest to the astronomy community, as opposed to an object that might be of interest only to me and not maybe anybody else. And that's true with the other facilities. Chandra works that way. Spitzer worked that way when it was operational.
During training, Steve, you obviously spend a lot of time with your colleagues, and in some respects became like family. Was that bond even tighter with Hubble, or was it fairly similar to what you experienced with the other missions?
No, I thought it was generally very similar. Maybe a little bit tighter with the servicing mission, because on the servicing mission, you really do spend more time working as a team. And that there's a little bit of additional bonding that happens between the two guys that are outside and me as the robot arm operator, and learning how to work together, learning, I remember on 82, Greg Harbaugh was changing out something called the solar ray drive electronics, and the commander was talking to the ground about something. Steve Smith next to me was talking to Joe Tanner out in the bay about something else. And so Greg and I couldn't really talk on the radio without stepping on these other conversations, but I knew exactly what Greg was doing and where he needed to go. And he knew I was watching him through the TV camera on the arm, and he just went like that. And I was able to move him, and then he went like that, and I was able to stop him. And you develop that kind of teamwork. And I suppose that leads to a little bit perhaps more camaraderie than just the normal teamwork that develops as a crew.
Sure. We've got just over 15 minutes left, Steve, so I'm going to start opening up for questions from the audience. There was a question about launch, specifically when the shuttle launched. How much was controlled via computer and how much was controlled via crew?
For launch, it's all controlled by the computer.
Yeah.
You have the capability to fly it manually if for some reason you need to, but that never happened in the whole shuttle program. Entry's a little bit different. It's controlled by the computer until you get down to just under Mach 1, and then the commander flies it manually. So all of the flying from ascent to landing is done by the computer except for the last 50,000 feet.
Do you hold the record for the lowest height to achieve MECO?
Well, I'm tied with with a few other people. Yeah,
for those
Wally
listening
Schirra
in,
and Stafford started it back in Gemini.
For those listening in, was it your first mission, Steve?
Yeah, it was my first mission.
Yeah.
And yeah, we got down to engine starts about just under 7 seconds. And so we got that far, and the engine started, and then they shut down. And so the story goes that, you know, I was sitting there and we're kind of still swaying back and forth on the pad from the impulse of the engine start. And out my overhead window, I could look over and I can still see the pad there. And MECO stands for main engine cutoff. And that was when I told the crew, maybe to just lighten the mood a little bit, that I thought we'd be a lot higher at MECO than this. It turns out that I didn't say that right away because we had a number of emergency procedures to go through. And in fact, I had forgotten. I was listening to a tape of that scrub a couple months ago, and I had forgotten that the ground still thought one of the engines was running. And we were pretty sure that it wasn't, but they kept calling us to shut down the engines, hit the push buttons to shut down the engines. I think what had happened was one of the engines actually didn't start, didn't get that far. The last engine didn't start. So they saw shutdown on 2, and the third wasn't in shutdown, but that was because it never started. Yeah, so it was actually some time before I made that comment, and nobody would know about it except that Hank Hartsfield had to do a press conference. And he told everybody at the press conference what I had said. And then it became public knowledge.
One of the listeners, Steve, wants to know if you have a favorite Hubble image.
Yeah, Bill Harwood asked me that several weeks ago. Bill was still is a space reporter for CBS, and my original favorite image was the deep field, the original deep field. In fact, I don't think it's hanging on the wall here, but I've got it here in the house that they sent me a picture signed by the director, because that was an area of the northern hemisphere sky taken sort of under the handle of the Big Dipper, which was away from the Milky Way, away from any known galaxies. And the question was, you know, if you just pick a blank spot in the sky and take a long exposure, what would you see? And I was surprised. What we saw basically were 1,000 or more galaxies in this one little tiny field of view. So that was my favorite for a while. In the last few years, I've actually had my own Hubble images for a research project I'm doing. And they're not very stunning just as an image, but for me it was really interesting scientifically, and so maybe that's my new favorite image is the
Sure.
one we got for our project.
Next week, this country returns to crewed flight. SpaceX is set to launch. What are your thoughts and any feelings as we begin to go into a new era of crewed flight in this country?
Yeah, it's going to be interesting to see how all that works. I mean, I'm glad that, frankly, that we're now being able to launch American astronauts on American vehicles. Um, I was never very happy about being solely dependent on the Russians for launch the space station. Um, it'll be an interesting. I am not an expert on all of the
Hmm.
arrangements anymore. I remember I had lots of questions about this when we started down this path back, whenever it was, 2010 or before. Um, and how are we going? It's a different ball game if you're buying a service, from Elon or from Boeing. How much does NASA get involved? I mean, NASA was in charge, and yeah, we had a lot of work done by the contractors, but we knew or had designed the testing that needed to be done. We had the requirements for certifying the vehicles for flight, and I don't know exactly how that's being done now. It must be acceptable to NASA, or they wouldn't put Doug
Right.
and Bob on the vehicle. Um, so it'll be different. Um, but I certainly hope it all goes just like we want.
One of our viewers, Steve, wanted me to let you know that Max Q rocks.
Well, yeah, Max Q was another casualty. We had a gig scheduled with the Orlando Philharmonic, actually on the day of the Hubble anniversary
Oh,
in
wow.
Orlando, and then of course that got canceled. But thanks for the plug.
Yeah, absolutely. Michelle, any other Facebook Live user questions? You can scroll down, Carla, to see if there's any. Well, we've got a few more minutes. Steve, any other reflections on Hubble that you would like to share with the audience?
Well, I don't know if this is generally interesting, but I share it with my students. When I was teaching at KU, I uh, remember one of the last classes I taught. It was a advanced course for our majors, and I was going over some recent Hubble discoveries, and suddenly I stopped and I looked out at the young men and women in the classroom, and I suddenly realized, far as they know, it's always been there. Their whole lives, Hubble's been in orbit. So instead of
That's
talking
interesting.
about the
Yeah.
scientific aspects, I talked about maybe the human aspects, kind of in the spirit of great things don't just happen. And you can go back to 1946, where legitimately the idea of HST was born in a paper by a famous astronomer, Lyman Spitzer. And that got some traction, and then other astronomers had to advocate for this idea, and they had to lobby Congress, and they had to get
Mhm.
enough interest in the community. And so in the 70s, Congress finally approved what at the time was the LST, Large Space Telescope, for development. And then it took, from 1977 or 78 until 1990 to get it, built and tested and checked out and ready to fly. And then, of course, we did get it into orbit, but then we discovered the mirror had an aberration, and so that took some time to overcome. So the whole point I was trying to make to my class was, to have something really important happen often requires, somebody with a vision, some people willing to
Mhm.
advocate for it, people that are willing to be leaders, people who are willing to be good technicians. You have to have the teamwork, perseverance, because you're going to run into obstacles. You need to overcome them, and you need to be able to continue to advocate. I mean, um, in 1990, well, late 90, we were in tough shape once the mirror problem was discovered, and and NASA was taking a lot of criticism, and people were struggling, and how are we going to solve this problem in the face of all the public outrage? But people did, and here we have a telescope that is 30 years old now and
Right.
has rewritten astronomy textbooks. And so anyway, that was the message that I was sharing with them, is that when you see something like that, don't think there was nothing to it. And so when you get involved in something later, expect to have to encounter problems and deal with them,
Right.
and provide leadership when you can, be a good team member when you have to, and persevere.
Steve, one of our viewers would like to know how you became an astronaut.
Well, when I was a kid, um, there were astronauts. I was uh, a big fan of the space program growing up, and followed all of the missions on TV, and uh, thought that was really fascinating. That you know, NASA appeared to be this group of men and women whose job it was is to figure out how to do things nobody knows how to do. But it never seemed like a legitimate career option for me, because I wanted to be a scientist, and all of the astronauts were test pilots, and I didn't want to be a test pilot. So it turned out it was really just kind of right place at the right time.
Mhm.
I was literally uh, in my last year of grad school, going to the bulletin board down by the office to see what jobs were available that I could apply to, since I was planning to get my degree that summer. This was in 1977. And uh, I saw this letter that had NASA on top. And so I started reading it, and they were talking about this thing called the space shuttle, and how they were going to hire astronauts, and how suddenly you didn't have to be a pilot anymore. You could be a scientist or engineer, and you had to have good eyesight, be able to pass the physical, had to have a bachelor's degree and 3 years of experience, which graduate school counted. And I remember I sort of dropped everything that I was doing, including writing my thesis, and applied to NASA. And I've shared this with the people who've heard this story before, is that I didn't apply with any expectation that I would be picked, but I applied because I could stand being told, well, thanks for playing, but you're not really what we're looking for. But if all of this came true, and we were launching shuttles and we were putting telescopes in space, would I regret that I never tried to be part of that?
Yeah.
And so I knew I could stand it if they told me no. I expected to be told no, but I didn't think I could live with, what if I had just, tried to do that? And so I applied, and by some miracle, got an interview. And I really thought, if my goal in all this was, could I get far enough along that they would fly me to Houston? I'd never been to Houston, never been to the Space Center, never met an astronaut. I thought, man, that would be absolutely cool if I could do that. And I did. They flew me down, and I got to meet some astronauts. And after the week of interviews and physicals and all that stuff, I felt like I'd won the lottery. I had gotten
Right.
what I was wanting to achieve out of this. So I never expected to go further than that. So
And your class was known as the 35 New Guys.
the TFNGs, yep, that
Yeah.
was class of '78, and most of those, my closest friends are still members of the TFNG class.
Yeah. Question from one of our viewers. They're asking about the technology of Hubble. They had heard some of the technology was based on military surveillance technology. Was that the case, or was it designed from scratch?
No, there were a lot of Hubble-like things being developed back in the day. So yes, it took advantage of some existing technology.
We've got about 4 minutes left, just a few more questions. One of our viewers asks, what was your favorite food in orbit?
Mac and cheese. I really liked the mac and cheese. A lot of it was pretty good. The barbecue beef was pretty good, but I think my favorite was mac and cheese.
And did you have specific wake-up music?
Yeah, we didn't get to pick it. It was picked for us by, uh, often the training team or the flight control team would pick it. Sometimes, uh, a family member might lobby for a specific song. Um, I don't remember many of the wake up music uh, that was played for us. I mean, I think they played the Navy hymn for the Navy guys that were on board, and um, but I don't know. I had a chance to. Um, I got a note from Michel Tonini, who was a crewmate of mine on SGS 93, and he was working, I guess, on some book project with somebody in France, and he was asking me if I remembered the wake up music from SGS 93, and I said I didn't, but I would see what I could find out. I went and looked up. Turns out NASA has a file online of all of the wake up music back from, I think they started in Gemini, but there are some blanks. And I remember in particular on 61C, which was my second flight, there are some days where nothing is listed. And so I got in touch with my crewmates from that flight and asked them if anybody remembered what the wake up music was on some, and we could help NASA out and help them fill out their database. And of course, none of us remember what it was. So,
Steve, one of our viewers would like to know what colleges you would recommend to get into NASA or areas of space. So outside of the University of Kansas, of course,
yeah.
are there other colleges you would recommend?
Well, I think the specific college isn't as important as the work you do while you're there. The kinds of degrees that are qualifying are technical degrees in science or engineering. At least for guys like me who are the non-pilots, a terminal degree is really helpful. So if you go to someplace where you can get a very good undergraduate education, do well enough to get into a good grad school, and then get a master's or a PhD, um, whatever's the best path for you to achieve that. I remember having an argument with my dad when I was picking colleges because I really wanted to go to KU, and he had other places he thought I should go that'd be better for me. My path worked out. So, I mean, there are a lot of intangibles associated with how someone is successful going through college and grad school. But the idea would be, unless you want to be a military pilot, to be able to get through a program successfully and show accomplishment in a technical field.
Steve, last question before we let you go today. One of our users asks, if you could design your dream science mission, what would it be?
Golly. Well, if I were a lot younger, I might want to go to Mars. But no, I mean, I would just talking science generally. I think my dream science mission would be a successor to HST, something that can take advantage of our 30 years plus of experience and how to design it, how to maintain it, how to upgrade it, that would continue to do the kind of astronomy that HST does. Because, as I say, James Webb will be fabulous, but it doesn't do what HST can do. And when HST can't do it anymore, we won't have that capability. So I guess, yeah, my dream science mission would be, HST, HST2.
Well, I would like to remind our viewers, if you would like to read Steve's blog, go to cosmo.org and look for Hubble Hugger. And then obviously more about Hubble tomorrow, virtual coffee at the cause at 9 a.m. Central. Steve, it's been a pleasure. I want to thank you for taking the time out of your day to be with us. I look forward to seeing you and Eileen back here at the Cosmosphere when this lifts. Thank you for all of the work that you've done, especially with HST. And we look forward to many more occasions to talk about it.
Thank you. I appreciate the opportunity, and I hope we get a chance to do this again.
Sounds good, Steve. Thank you.
All right. Take care.
All right. Bye.
Bye-bye.